All right, let's go. Let's talk about, this time we're going to talk about solving radical equations. Okay? And these look complicated, but they're really not that bad. Okay? The biggest thing is we have to isolate the radical expression first. Okay? Just like if you think back when we were solving absolute value functions. Okay? Those equations. We need to isolate the absolute value. The same thing works here. We need to isolate the radical. Okay? So if we take a look at this example here, 3 plus the square root of 2x minus 3 equals 8. Now, as always, we're solving for x. Okay? Step 1, isolate the radical. Well, we're adding 3, okay, so we need to subtract 3 from both sides. So then we get the square root of 2x minus 3 equals 5. Okay? Now, we want to eliminate the radical. So to do that, we do its inverse and we square it. Okay? So we've got square root of 2x minus 3 squared, but what we do to one side, we have to do the other side, 5 squared. Okay? Now, these two just cancel each other out, right? So we get 2x minus 3 equals 25, and from that point on, it's pretty easy. 2x equals 28, x equals 14. Okay? So, isolate the radical, convert to exponential form, which we did here. Okay? Raise the expression to the power of the reciprocal, which we did. Okay? So let's look at another example. Here, you're really going to see this part here. Raise the expression to the power of the reciprocal. That's going to be very, very important. So we've got 3 times the quantity x plus 1 raised to the 2/3 power equals 12. Number 1, isolate the radical expression. So we need to divide both sides by 3. So that we get x plus 1 to the 2/3 power equals 4, because these cancel. Now, I've got a rational exponent here. So to get rid of it, I need to raise it to the power of its reciprocal. Okay? So I have x plus 1 to the 2/3 power. Then I'm going to raise that to the 3/2 power. Okay? And then that's equal to 4 also to the 3/2 power. Okay? So I've got the quantity x plus 1 to the 2/3. I raised it to the power of its reciprocal, and I did the same thing to the other side, because we always have to do that. Okay? So these are going to cancel, and I just get x plus 1 equals 4 to the 3/2 power. Now, let's see what it looks like in radical form. X plus 1 equals square root of 4 cubed. Well, what is the square root of 4 cubed? It's the square root of 64. So x plus 1 equals 8. So x therefore equals 7. Okay? So the biggest thing here, isolate the radical expression, which we did here. Convert to exponential form, which we did here. And then raise the expression to the power of the reciprocal, which we did right here. All right? Let's look at another example. All right, here I've got 3 times the 5th root of the quantity x plus 1 cubed plus 1 equals 25. Step 1, isolate the radical. Okay? So I need to subtract 1. So I've got 3 times the 5th root of x plus 1 quantity cubed equals 24. okay? Divide by 3, cancel, cancel. Fifth root of x plus 1, quantity cubed equals 8. All right? Now, let's convert this to exponential form. X plus 1 quantity to the 3/5 power equals 8. I don't have to do anything on the right because I haven't really changed anything on the left. All I've changed is the appearance. I've gone from radical form to exponential form. So I don't have to do anything on the right side. But now I want to take x plus 1. Sorry, a little sloppy. That looks terrible. All you OCDers out there would be going nuts, right? To the 3/5 power raised to the, okay, what am I going to raise that to? The 5/3 power equals 8 to the 5/3 power. All right? So right here, that cancels, and here I've got 8 to the 5/3 power. Okay? I'll raise that up a little bit. Okay, let's convert this back to a radical form and see what it looks like. Cube root of 8 to the 5th. Okay? So we could take a look at this, and we can look at this a couple different ways. The cube root of 8 is 2. So that becomes 2 to the 5th, which is 32, subtract 1, x equals 31, which you can see my little cheat sheet here. Make sure I'm keeping myself honest here, because math teachers make lots of mistakes, okay? Don't let them tell you any different. All right, now, we've talked about extraneous solutions before, okay? And remember, an extraneous solution is just a false solution. It's a solution that's not, it doesn't work when we substitute it back into the original equation. We have to check for that, okay? So let's see what that looks like. Move this up a little bit. Okay, so we need to isolate the radical. So I'm going to add 5. So I have square root of x plus 7 equals x plus 5. Okay, so now I'm going to square that. And I'm still taking the reciprocal, okay, because here I have a 2, here I have a 1. So this is to the 1/2 power, so the reciprocal of 1/2 is 2. So I'm still taking the reciprocal. I'm still following my plan here. X plus 5, quantity squared. Okay, these cancel. This becomes x plus 7. This becomes, if we expand this binomial out, remember, square the first term, x squared, multiply these together and double it. Square the last term. Okay, so now we have a quadratic trinomial. Don't let that scare you, okay? So I'm going to subtract x. We're going to set it to 0. So I get 7 equals x squared plus 9x plus 25. I'm going to subtract 7. So I get 0 equals x squared plus 9x plus 18. If I factor that trinomial, it's going back to your quadratic days, right? Getting real basic here, okay? 6 and 3, set those to 0, okay? X equals -6, x equals -3, okay? So, we've got x equals -6, x equals -3. If we substitute those back in, we have to see if we get an extraneous solution, okay? And when we do that, when we put -6 in, we find out that that doesn't work. So that is an extraneous solution, and -3 is our only true answer in this case. Okay, let's look at another one here. Subtract 3, 5x minus 1, x minus 3. Square both sides, okay? So if I square both sides, remember, we are squaring the quantity. You can't just stick a 2 out here and square that 3. Okay, that would be wrong. We have to square that whole quantity. We have to square the whole side there. Here, the square root and the square cancel out. 5x minus 1 equals, expand this binomial, minus 6x plus 9. Okay? Add 1. Okay, subtract 5x. Okay? Factor it. Okay? And then what I want you to do here we have x equals 10. Here we have x equals 1. I want you to substitute those back in to the original equation and check yourself for an extraneous solution. Okay? Now, if you throw this into your graphing calculator and set these up as two different equations, here we have y equals x, and here we have y equals square root of x plus 7 minus 5, okay? And you get your graph, and you'll find where they meet. So that is one way of doing it from a graphing standpoint, okay? Now, sometimes on your graphing calculator, you know, that can be a little cumbersome because your viewing window's not great, but you can use your intersection mode on your calculator and see where those two intersect. I'd kind of like for you to do it algebraically though, for now, okay? And we got 12 minutes. Okay, I need to be quick here. Now, what happens if we have two radicals? Nothing. We just isolate the more complicated one first. Okay, so I have square root of 2x plus 1 equals 1 plus square root of x. All right, now I'm going to square both sides. Use colors here. Square that and square that. Okay, so here I get 2x plus 1 equals 1 plus 2 square root of x plus x. Okay, now I've got to isolate the radical that I have left. Subtract 1, I get 2x equals 2 square root of x plus x. Okay, now I'm going to subtract x. Okay, subtract x. X equals 2 square root of x. So now I'm going to, get my colors again here, square both sides, okay? So I get x squared equals 4x. Subtract 4x from both sides. Zero product property, okay? Here I can divide out an x, set both factors to 0. There you have it. But what do we have to do? We have to check for extraneous solutions. So check for extraneous solutions. All right, that'll do it for today. I hope these help. Miss you guys. Stay safe.